Hi everyone. So during this lecture, I'm going to explain how do we solve a quadratic equation using the discriminant delta. First of all, I'll start by reminding you by the standard form of a quadratic equation, which is ax squared plus bx plus c equal to 0. And since I'm going to use delta, first I'll have to define delta as the constant number which is equal to b squared minus 4ac, where b is the coefficient of x, a is the coefficient of x squared, and c is the constant part. Now if you look at the number delta or the constant number delta here, we may think of three different values of delta. Delta can be positive, delta can be equal to 0, or delta can be less than 0. And it's important, guys, to notice the sign of delta so we can study the existence of the roots, and later on it will help us to find the roots of the quadratic equations. In which, if delta is positive, this means that we have, or we can speak about the existence of two different or distinct roots. While if delta equal to 0, then we have one double root. And finally, if delta less than 0, then we have no real roots. And now I'm going to start with the first case, in which if delta is bigger than 0. If delta bigger than 0, this means that, as we said, we have then there exist two different roots. I'm going to call it as x1 and x2. And in fact, we can directly find these roots using the following equation. x1 equal to negative b minus radical delta over 2a, and x2 equal to negative b plus radical delta over 2a. And of course here radical delta is defined because delta is positive. Now in the next case, case number 2, if delta equal to 0, we have one double root, and x1, in which x1 equal to x2 equal negative b over 2a. Of course, if we want to prove why they are equal, we can go back to the first case in which delta is positive and replace delta by 0. If you look at x1, if delta equal to 0, then you will get negative b minus radical 0 over 2a, so it's negative b over 2a. Same thing, x2 equal negative b plus radical 0 over 2a, so it's also negative b over 2a. And also, we can deduce that if delta less than 0, we don't have real roots simply because delta negative, and we cannot use negative numbers under radical. I will be solving examples in my next video about how do we use delta in solving any quadratic equation. Thank you for watching.